Okay, once again, we made a video a little while ago. It took 15 minutes to explain it, so we're going to try to make a short 3-minute video just to cover the real quick basics on how to build a winning Pinewood Derby car. Once again, this is the Pinewood Derby car that Michael and I used to win overall champion. Okay? And as you can see, there's absolutely nothing special about this car. Very, very simple.
People were laughing at it.
People laughed at this car when they brought it in there, but it ends up winning Grand Champion. And here's how we do it. Okay? First of all, you got to understand the basics of a Pinewood Derby car. Or a Pinewood Derby race. You've got a slope, then an angle, and then flattening. All right? The bottom line is, right here is the most important part. Right? Every object drops at 9.8 meters per second squared. Okay? This is going to be at a slight angle, so it's going to alter that. However, it's this drop that is what is important, because what happens is it drops for this period, and right there it is taking potential energy and accelerating it, maximizing the kinetic energy right when it reaches the flat spot. Once it reaches this flat spot, it no longer continues to accelerate. Then it's just simply the momentum that is generated to make it through the end. Okay, so it's this drop that is most important. What we did with this car was we maximized the drop. How did we do that? This is a normal Pinewood Derby car. They have the axles about right here. Right? What we did was we cut it right down here, and we cut it right down here, and then we spun it around. And by doing that, by spinning it around, we were able to take those two additional parts and basically move the axle all the way out to the very ends. Right? We had it cut here, and we just simply glued this back together. We then cut it right across here to make it very thin. And this is what our car looked like. You had two glue strips. We had the axles at the very end. And that is why the wheelbase is so big with this car. The wheel is here at the very end. The wheel is there at the back. What that did was, that took care of this step. We maximized the amount of drop, that maximized the acceleration, that maximized the kinetic energy, because once it reaches here, the kinetic energy then becomes momentum, which is MV. It's accelerating, and then it's slowing down. Now, once it gets to here, the main thing is addressing the friction. We wanted to minimize the friction. How did we minimize the friction? We looked at every single surface where there's surface on surface and rubbing. Most of it comes into play with the wheel. All right, you have the wheel. Okay, the wheel touches the rail, it touches the floor, and it touches the wood. And the nail touches the wheel. So you've got touch point here, touch point here, touch point here, touch point here. How did we address that? The main thing we did there was we took the wheel, okay, and when in order to minimize the friction against the wall, we filed it a little bit. Right? So we took this much surface area and reduced it down to this much. That way, only this area was touching the wall. Down at the floor, once again, we narrowed it in a little bit. Right? So once again, we had very little area touching the floor. On this part, we took the nail, put it through, and we ran the drill, so we made sure that this area was very well buffed in. We also took the nail, and we did two things to the nail. One, the nail has a flat head like this. Right? We took it and we buffed it out, so we reduced the amount of area that the nail was touching the wheel. Okay, it went from being this much to only this much, this little area right here. We also took the sander and buffed the nail for the part that touches the plastic, and we filled this area in here with the carbon, what's that called? It's graphite. We fill it with graphite. Okay. We also then what we did was we put a index card between the wheel and the Pinewood Derby, so that there was just a small gap between the wheel and the wood, and that reduced the minimum shake back and forth of the wheel. So when I go like this, that wheel just spins and spins, and it doesn't go back and forth. Those were the key principles behind it. Number one, we maximized the height. We did that by stretching the wheelbase. Two, we minimized all the friction by putting graphite on the axles, and we filed the wheels, and we buffed up the nail to make sure that anytime there was a surface on surface, we minimized it. And that's how we ended up building a winning, record-setting Pinewood Derby car. It didn't take very much time at all. It's very simple and looks awkward, but it wins races. Thank you.